Hello, I am Ben, and this is my study guide for OCR A-Level Computer Science SLR2 types of processors and the study guide I've made for it. This is not an in-depth like materials, but a quick review of the materials and the key ideas that you need to know. So an instruction set. An instruction set of all instructions is written in machine code so that it can be recognized and executed by the given processing unit slash CPU. And then CISC is very common, and CISC is an complex instruction set computer. This was the term given and coined for a non-RISC processors. CISC processors tend to have a larger instruction set, including very specialized instructions, at a very fundamental term. RISC. So reduced instruction set computer is a design approach where the CPU uses a small set of instructions, where this means it's lost more specialized tasks but allows for more efficiency in processor design. So the differences in comparison between CISC and RISC processors is like a RISC processor have a smaller range of instructions than CISC processors. The small instruction means fewer transistors um, are needed. Therefore, they generally require less power and are less and more cost effective to produce. And then the instructions in a CISC processor tend to take several clock cycles to execute, while RISC instructions usually take a single clock cycle, making them better suited for pipelining. And then compilers in RISC processors tend to be more complicated, so for a given program, more instructions are likely to be generated. And then, furthermore, RISC processors have fewer addressing modes than CISC processors, but a more general purpose registers. So, um, basically, a CISC basically allows more complex computing, more multi-purpose and whatnot. So like that's what a laptop would have, more complex devices, where a RISC processor will have more few instructions made for a very specific task, allowing for pipelining and very efficient use of that very specific task. An encode processor is an additional processor used for a very specialized task. Its overall purpose is to improve the efficiency for the computer, and a great example would be a GPU. A GPU is a graphical processing unit that specializes in the processing of graphics and rendering of graphics in vectors, 3D vectors, colors, etc. And it's not just used in like computer games and whatnot. It can be used for engineering models. It can be used for modeling oil. It's really used anything really good for graphics and model rendering. And then like modeling, it could be great for also very algebraic linear calculations in that sense. So, like we just said, the graphical processing unit is used for rendering graphics, but it's not limited to graphics. Its GPUs are highly specialized. GPUs and the CPU have very different tasks and performance characteristics. GPUs tend to be better on a lot simpler operations on large data sets. GPUs are very good at performing calculations on matrix, vectors, and a multiple data at the same time, such as render graphics on other modeling tasks. Other uses for the GPU include oil exploration, weather modeling, machine learning, linear algebra, statistical analysis, stock option predictions, and gravitational field theory. Think of GPUs as a special purpose processor designed to do a single instruction that can work quickly over a large block of similar data, applying the same operation again and again and again. And that's why they're really good for graphics and like video games in that sense, because you're doing the same sort of linear calculations and rendering again and again and again, but very, very quickly to have a functioning video game. So a multi-core processor is when basically a single chip contains two or more independent processing units. Each core can fetch, decode, and execute its own instructions. These are single physical chips known as chip multiprocessor (CMP). CMP2 cores is a dual processor, and CMO 4 cores is a quad core processor. The performance of multi-core processors is enhanced by one chip shared cache and inner core communications. Not all cores can make use of not all programs can make use of multiple cores. For example, if a program is an older program or is not designed to make use of this, it just can't take advantage. You'll have to just use one single core. It can't make use of the four cores in the shared cache effectively. So it has pros when the program and functions are designed to be used in that sense, but not always. Parallel processing. Parallel processing of a program instructions is by dividing them between multiple processors or processor cores. So um, it, basically parallel processing can speed up communication, but it's dependent on the task being carried out and the software that is designed to be carried out. It's different than pipelining, but it can be very good when there's multiple cores available and processing units available. Basically, where it's fetched in one core, it's going to be executed in another core and decoded and executed in another core. In that sense, it's very effective, but it can be also be used with pipelining, but it is also not pipelining. Thank you. That is it for today. Thank you for watching this video if you've got this far.